Okay, in this video we're going to investigate a property called resistance. And introduce a law called Ohm's law. Now, if I just set up a very simple circuit here and don't include any components, let's just have our wires go into our battery, you can see that our current is really high. In fact, will our ammeter even measure it? Let's have a go. So we're currently at a current of 169,000 amps. And you can see that current means our charge is flowing really fast, causing lots and lots of heat and causing our battery to set on fire. And this is why you should never short circuit a battery. Okay, now let's put this component in called a resistor. Now, resistance is the opposition to this flow of charge, and it's caused by the structure of the metal resisting that flow of electrons through. They bump into all the positives in the metal, slows them down, and what I'll do is I'll link some other YouTube videos describing what resistance is, so you can watch them. Okay, so in terms of what I want you to do now, we're going to investigate this resistor. So what I would like you to do is to set up this circuit. We've got a resistor, we've got an ammeter, and we've got a voltmeter across it. What I would like you to do is, in a spreadsheet, doesn't have to be Excel, I'm quite lucky I've got Excel. If you cannot get onto Excel because you don't have it at home, don't forget you can via a web browser, but here's Excel. Okay, so what you're going to do is set up two columns. You're going to have one called voltage in volts, one called current in amps. Let's make sure we use our correct symbols. So that's going to be a V. And what I'd like you to do is, using the battery, is change the voltage. You can start with 0, so we have 0, 0. What I'd like to do is to change the voltage on this battery all the way up to 9 volts, and record the current as you're doing it. Okay, so this is the table you should start off with, voltage and current. And what you're doing is, by changing the voltage on here, you are going to very slowly, if you use this, probably better, you can, no you can't type in here, so you can use this and you can then record the current as you go. Okay, pause the video now and do that. Okay, welcome back. So, this is the results I got. Yours might vary, you might have changed a few things, but this is very similar to what the results you should get. Now what I'd like to do is to plot a graph. If you have graph paper at home, you can do this by hand, or you can use Excel. So we'll go Insert, and we want a scatter graph. Okay, this is what we call a line graph in science, but a scatter graph on Excel. What I'd like to do is go down to Move Chart, and just move it to a new sheet so it's out of the way. And we get our lovely line. Now, again, if you print this off, you can do this by hand or do it on the computer. Add trend line. You want to set the intercept to 0. And if we display equation on chart, that helps us as well. Nice straight line, and we get this graph. So we've got a lovely straight line going through the origin, and we've got this equation here. Now, Ohm's law states that the voltage, which is our x-axis, is the current times resistance. Now, our equation's the other way around though, so this is current, y in our case is current, x is voltage, so we've got the rearrangement here, and the rearrangement would be current equals 1 over resistance times voltage, or voltage divided by resistance. Okay, so this 0.1 is the gradient of this line, or is 1 divided by the resistance. So what we can get is the resistance of this resistor is 1 divided by 0.1, We rearrange it for that, and we get our resistance to be 10, and we can see that here, that we have a resistance of 10, hopefully. Okay, so that's a simple thing of Ohm's law. Alright, and again, I'll link some videos going more into that. Alright, thanks for watching.